So we're going to go over the warm-up after you've had time to work through these problems. End behavior and graphing means as x positive infinity, that is to the right. What is y doing? Is it going up? That would be positive infinity, or down, negative infinity. And as x goes to negative infinity, that is to the left. What is your y value doing? Is it going up, which would be positive infinity, or down, negative infinity? First graph. We can see that on the right-hand side, it is going up. On the left-hand side, it is going up as well, which means it is an even degree, positive leading coefficient as well. For this one, you can combine and say as x goes to plus or minus infinity, y goes to positive infinity. You could also separate that as x goes to positive infinity, y goes to positive. As x goes to negative infinity, y goes to positive. Second problem. You can see it's down on the right, up on the left, which means it's an odd degree. You were also asked, is it even or odd? And it's down on the right, which means a negative leading coefficient. On the right-hand side, we would say as x goes to positive infinity, y goes to negative infinity. On the left, as x goes to negative infinity, y goes to positive infinity. That's up. Next graph. It's up on the right, down on the left. That means odd degree. It's a positive leading coefficient. As x goes to positive infinity, y goes to positive. That's up. On the left, as x goes to negative, it's going down. Y is going to negative infinity. Next problem. Even degree because it's up on both sides, on the right and on the left. And again, when it's even, you can combine as x goes to plus or minus infinity, y goes to positive infinity. Positive leading coefficient there. The next graph is down and down. That's an even degree because it's pointing the same way. It's negative leading coefficient since it is down. And you can say as x goes to plus and minus infinity, y is going to negative infinity. Last graph is an odd degree. It goes up on the left, down on the right. It's a negative leading coefficient because it's down on the right. On the right side, as x goes to positive infinity, y goes to negative infinity. That means on the right it goes down. On the left, as goes to infinity, y goes to positive infinity. That means it's going up on the left. Next set of problems is asking you to use the degree and the end behavior to match each polynomial function to its graph. This first one on the left is going up and up. That means it's an even degree, positive leading coefficient. There are two real solutions to x-intercepts, and there could be some, other additional solutions that are not x-intercepts, but for now, these are our x-intercepts, and they are crossing, which means it's, again, some kind of an even degree. It would be either B or C. Those are even degrees. And let's see, because it's positive, going up, only B is possible. C has a negative leading coefficient. The next one over is down and down, so that's again an even degree. It is negative because of the down. There are two intercepts, which, could be different multiplicity there, but anyway, even degree was also C, and that matches with the negative, so this is graph's equation C. The next graph over is down on the right, up on the left. That's odd, and it has a negative leading coefficient. A is odd with a positive leading coefficient. Equation D is odd with a negative leading coefficient. And so this can only be graph D. Last graph is up on the right, down on the left. That's odd for degree, and it's a positive leading coefficient. So in fact, it does match the only equation that's left, which is equation A. The next page was asking you to make sketches. So it does not have exact. Think about end behavior zeros. Those are the x-intercepts. Whether it crosses or bounces is tangent to the x-axis. And it says not to worry about finding local mins or maxes. Number 3, it's negative x is a negative x cubed equation. That means it's an odd degree, and it's down on the right, up on the left. Your intercepts are 1, -2, and -1. Plot them. And then again, you have a multiplicity of 1 at each intercept, so you're crossing the axis. So down, up, cross, cross, and your y-intercept was negative times negative is positive, times 2 times 1 is positive 2. Number 4, x to the 4th, x squared means you have x to the 6th overall. That's even. It's positive, so it's up and up on either side. At -3, you have a multiplicity of 4, and at +2, you have a multiplicity of 2. Those are both even numbers, so they are tangent to the x-axis, or it's a U-turn or a bounce. When you plug in 0, you get 32, so 3 to the 4th times -2 squared. Sorry, that's 324, so that's a huge number. And again, you've got your 2 intercepts. At -3, the multiplicity is 4, so it's got to be a little bit flatter here than here. So you're pointing up at the end, you've hit the x-axis, turn around, grab your y-intercept, go back to 2, and you sort of quickly hit 2 and bounce back up. Number 5, negative x squared x is x to the 4th. Negative means even, and negative means down and down on the ends. You have an intercept at -5, +1, -2. At +1, we have a multiplicity of 2, so that's an even, that's a bounce or U-turn, and at -2 and -5, you are going to cross the x-axis. So you start off by doing down, down. Your y-intercept is at -10. So again, you U-turn when you hit 1, catch your -10, y-intercept, go through -2, and then cross through -5 to go back down again. Number 6, x to the 4th, x squared, and another x is overall x to the 7th. That's an odd degree. It's a positive leading coefficient. That means up on the right, down on the left. Intercept at -6 with an even multiplicity, so it's going to U-turn. At -2 with an even multiplicity, that's a U-turn. And at +3 with an odd multiplicity, it's going to cross. Your y-intercept is some really big negative number. Work it out if you want. Because you're going up here, we're going to go back down, cross at 3 to the negative zone, hit our negative y-intercept, go up to -2, sharply bounce, go up to -6, kind of hang out here on the x-axis a little bit flatter, and then turn around and go back down. It's just a sketch. You can make that dotted in between if you like. Number 7. Negative x times x times x is -x cubed. That's an odd degree. Negative means down on the right, up on the left. You have an intercept at 0, x and y, -1 and 4, so down, up, and you're going to cross at each intercept. Last but not least, number 8, you have x times x squared times x again is positive x to the 4th. That's an even degree. Positive means it's going to be up and up. 0 is an intercept, 5 is an intercept, and 2 is an intercept. At 2, you're going to cross through the x-axis, and at 5, you're going to bounce or U-turn or be tangent, and at 0, you're going to cross. So if you start here, you cross, you U-turn, and go back up. That is it for the warm-up. Take a minute and fix up anything that needs to be fixed, and then we will head on into the notes.